Hey, hi, I'm Ramya, embedded software engineer at Microsoft Technologies. Welcome to this video demonstration of system tick frequency adjustment and measurement project using TDCI and Cortex. In this project, we will explore how to configure and measure the system tick frequency, control the delay based on this frequency, and observe the behavior of an LED that toggles at expected intervals. So let's see what is TDCA first. TDCA is Target Device Communication Interface. TDCA is used to send and receive the data between microcontroller and the host system using the serial communication. So this host is sending a command using the serial communication to the target hardware, either Cortex or Arduino, anything. So this target hardware processing the command and then return back the response data to the host via the serial communication. So this is the mechanism we are using in this TDCA. So let's see the overview of the project. The Cortex microcontroller allows us to configure the system tick frequency, which is essential for creating time delays in embedded systems. So the system tick is used to control the timing for delays in the project with a focus on accurately adjusting and measuring the tick frequency. The LED toggles at intervals controlled by the system tick frequency, providing a visible indication of the adjustments being made. TDCA facilitates the communication between controller and the host, enabling real-time measurement and adjustment without requiring the reprogramming. So let's see the components we are using here. LED, which provides a visual representation of the timing behavior, turning on and off at intervals that reflect the current system tick frequency. And the microcontroller, which is Cortex, this is the core of the system responsible for controlling the system tick frequency and toggling the LED. So these are the components we are using here, and the main mechanism is TDCI. So this enables real-time feedback to the host system, making it easier to monitor the tick frequency and adjust configuration without reprogramming the microcontroller. Okay, coming to this coding part, we should include the TDCA.h header file to use the TDCA API calls. And from OS application start function, this is like a main function. So inside this, you will declare TDCA init with your comport. So this is the one making the communication between host and target. So make sure you initialize this one in the beginning of your code, and then set the pin and port as whether it is input or output. This is also necessary to use a particular pin and port. Okay, and then we're going to use HAL set tick frequency. So this function calls set the system tick frequency to a specific value like 1 kilohertz. So which means one tick per millisecond. So we are going to get after that get the tick frequency. So this function called retrieve the current system tick frequency, which we then use to calculate the time delays. So inside the while loop, toggling a LED on a particular report and pin, and then the HAL delay function is modified to use this frequency calculation to create precise delay intervals for toggling the LED. So the delay interval is calculated using the formula 1000 divided by the tick frequency. So to achieve a 1 second delay. So for that we are doing this calculation. Inside this while of one, the LED is toggling using this toggle pin API, and the calculated delay is applied using this HAL delay API. So the system tick is a timer that generate periodic interrupts at a fixed frequency. In this project, we set the tick frequency to 1 kilohertz, so 1000 ticks per second, which meaning one tick occurs every millisecond. Okay, I'm going to run this project now. So you can see the command is started running. So we seeing the response from the target board also, and each API is running. Based on that, we are getting a success status from the target end, and also set frequency and get tick frequencies also started running and giving a param value. So based on that, my LED will start toggling with the calculated delay. So you can see at each state my LED will on and off with the period of this calculated delay. Okay, now let's see the hardware setup. So this is my hardware setup: Cortex microcontroller and LED. I gave the required connection with positive supply and negative supply to the LED. So before start this project, make sure you reset this board. Now I'm going to run this project. Started running this project, so each command will execute one by one, and then my LED will start toggling. You can see that my LED is on now. So with the preferred delay, it is going back to the off state. So like this, my LED will toggle on and off based on this calculated delay. So the tick frequency we set here is 1 kilohertz, and the delay interval is calculated as 1 second using that formula I showed you. So the LED connected to the particular pin which toggles on and off at 1 second interval. So demonstrating how time-based operations are controlled by adjusting the system tick frequency and applying the appropriate delay calculations. So this is how we achieve this project with particular delay interval. So we can use this project in various practical application, such as real-time system, which is the precise time control is essential for periodic task execution and real-time operations, and also sensor data processing, where we can monitor on environmental monitoring, which can benefit from this approach, and also actuator control, so like motor servo adjustments, and rely on accurate delay calculations. We can use this project. So we can, like this, we can apply it in various applications. So in conclusion, this project demonstrate how to simulate time progression in an embedded system by manually adjusting the system to frequency, by applying a mathematical calculation to control the delays, so we can achieve a precise timing for various embedded applications. Thank you for watching. So that's it. Thanks for tuning in. If you found this helpful, stay connected for more artist related videos. Bye.